So hello guys. So in this lecture, I'm going to teach you uh, uh, what is LangChain and what is its component. Okay. So here I am going in the document of LangChain. Okay. So here you can see introduction. Okay. So LangChain is a framework for developing application powered by large language model. Okay. So LangChain is a framework for developing application powered by LLM models. Okay. So here also we can see in Geek for Greeks. Sorry. So LangChain is an open source framework designed to simplify the creation of the application using large language model. It provides a standard interface for integrating with other tools end-to-end chains for common application. Okay, so it helps developer to connect LLM such as we can connect our LLM such as GPT-4 with the external data and computation. This framework come for both Python and JavaScript. Okay, so we are learning it with the help of Python, so we can see everything here with Python. Okay, so key component, it has modular for workflow, simply chaining LLM together for reusable and efficient work. Okay, like if you have a lots of thing or like you use different tools and different API, then you need to create some tool, and we can combine this thing by using chain. Adding something, so we have created chain. Okay, and we can be here another key component is prompt management, offer tool for effective prompt engineering and memory handling. Okay, so here different kind of prompt that we can use in our project, like a system prompt, AI prompt, user prompts. Okay, and few short prompt, zero short prompt. Okay, so we will learn this. Okay, and use of integration streamlines the process of building LLM powered application. Okay, and after that I need to check key components. Okay, so here you can see LangChain, this provide a vector management, memory management, models, chains, okay, agents, okay, prompts, and vector database. So here we need to see chain define sequence of the action. Okay, like if you have different actions, uh, and then you want to combine it, so it is a sequence of the action where each step can involve query and LLM manipulating data or interacting with external tool. There are two types: simpler chain, okay, a single LLM invocation. Okay, multiple step chain, multiple LLM or action combine. Okay, so like if you have multiple LLM or you have multiple actions, then you need to combine it, that it will create a one chain inside different actions and tools it has. Okay, so where each step can take the output from the previous step. Okay, and second is prompt management. LangChain facilitated manage and customize the prompt passed to the LLM. Developer can use prompt template to define how input and output formatted before. Okay, so we can use prompt like how input and output are formatted before being passed to the model. Okay, so if you want to pass something into the model, some text or sentence, so you need to give a prompt in proper way, or how do you format it. So we can format it by using prompts. The model then after we passed it to the model. It also simplified tasks like handling dynamic variable and prompt engineering, making it easier to control the LM's behavior. And after that we have agents. Okay, agents are autonomous system within LangChain that take action based on inputs. They can call external API or query database dynamically, making decision based on the situation. These agent leverages LLM or decision making, allowing them to respond intelligently to changing input. Okay, so agents it automatically did things, your task, and it will automatically call your API. and after calling API, it will take decision by its you I mean by your own, and it making decision based on the situation. It doesn't need any human intervention. Okay. So here, third is vector database. Okay, so LangChain integrate with the vector database, which is used to store such high dimensional vector. Okay, so we have different vector database like FAISS files and baby 8 pinecone neon. So neon. So we have different vector database. Like if you have a text, then you can't give it to the model directly, so you need to convert it into a vector by using embedding, and you need to store inside the vector database. Okay, so here we can also check. mm, so they also have LangGraph platform. Okay, integration and LangChain LangGraph. Okay. So guys, in LangChain, we have different components. These are chat model, message, chat history, tools, tool calling, structure output. Okay, memory, multimodality, runnable interface. Okay, so the base abstraction that many LangChain component and LangChain expression language are built in. Okay, so here you can see here there is a different retrievers, vector store of stores of one of an efficient search over vector and associate metadata. Okay, they have agents. So these are the components of LangChain. So we are going to learn few from this. Okay, so if you need any other another component to use in your program or in your code, then you can go through with this document. Okay. Okay, so after this vector database, mhm, models. LangChain is a model agnostic, meaning it can integrate with different LLMs such as OpenAI, GPT, Hugging Face model, DeepSeek, R1, and many more. Okay, and after that we can do many memory management. So LangChain support memory management, allowing the LLM to remember context from previous integration interaction. Sorry. So here, how can LangChain work? Okay, so I have similar diagram in my PDF. So where is it? Where is my PDF? So key component of LangChain in RAC pipeline. So we have data integration and transformation. Okay. Uh, first of all you need to have sources like what kind of data you want to take inside LLM, and you want to send how many things in document like tables or handwritten notes or images. So I mean, first of all we need to source where I will get my data. So sources are PDF, text file, or website or database APIs. Okay, loader specialization connector. LangChain provide many to fetch data. Okay, so we can load our data by using loaders. Splitter means break data into a smaller chunks. Okay, like if you have lots of data, so we need to create it chunks. Okay, so by LLM can't handle very large document directly. Okay, so because LLM have context window limit. Okay, Context means flow, I mean information, some amount of information we can pass inside the LLM. Okay, so because LLM have context window limit, they can only process with the fixed number of the token at once. If document is too large, it won't fit entirely into the model context, so we need to split it into a smaller chunks. This allow the LLM to process and retrieve only the relevant part instead of being overloaded with the entire document. Okay, and here after loading document, after chunking, um, we need to create embedding and store it into the knowledge base. So here embedding model, so we have different embedding model. Convert here, first stage we need to convert text into a high dimensional vector that captures semantic meaning. So example, these are the we can use OpenAI, Hugging Face, or local embedding model. Okay, like sentence transform from Hugging Face. Okay, so here in vector database optimized for similarity search, files, chroma, and pinecone baby. So store both vector embedding plus original text here in vector database. By so you can later find the most relevant chunk for a query. So exactly splitting document into a smaller chunks allow you to later embed those chunk and store them into a vector database. Okay, and when a query comes, instead of searching entire huge documents, you compare the query embed within the chunks embedding. This way, the system can find only the most relevant chunk and pass them to the LLM for generating a precise answer. Okay, so here by using this way, the system can find only the most relevant chunk. Okay, most relevant from the query. Okay, if you ask something about Delhi, or if you ask something about the president of America, then it will search most related query and from the vector database and pass this query to the LLM to generate a precise answer. Okay, so retrieval and context injection, user query, convert the question into a embedding vector, and find and retriever find the most similar chunk into the vector database. Okay, so if you ask this some question, who is that Donald Trump? Okay, so after asking this question, I think things will do like first of all we need to create embedding of the this sentence. Okay, so we need to convert it into in embedding vector, and after that find the most similar chunk in the vector store. Like I have a question like who is the president of America. Okay, so it will goes in our vector database after creating embedding and find similar things, I mean similar chunk inside the vector database. And third thing is prompt construction, combine user query. Okay, like question what you want to ask, and retrieve chunks like what model give us. Okay, so we are going to combine these things, user query, and retrieve chunks into a well structured prompt. Okay, so why this is why given the LLM external knowledge beyond its training data. So the LLM normally only know what it was trained on. Retrieve let it, I mean LLM normally only know what it was trained on. Okay, so LLM only know things like it was a trend on. Okay, so in previously in what kind of database model trend on. Okay, and retrieve lets it look up new information. Okay, so here if you want to retrieve new information from LLM, then use that to answer the question, so it can handle things it doesn't learn before. Okay, by using LLM external knowledge base. Okay, beyond its training data. Okay, so like our LLM work on older data, not updated with new data. Okay, so we can do things, and we use different things like user query retrieval and prompt construction by using RAG. So this will generate a new answer or information. It can handle things it didn't learn before. Okay, it look up new information about the query. So here first step is our first step is data injection and transformation, where we got our data. Okay, and we need to transform by using pdf uh, um, pdf loader, text loader. Okay, and split in data injection we have this thing: source, pdf, text, file, website, or you can use url. And then transformation, we split into a break and smaller chunks, so we have different splitter like um, mm, we will know it in next lecture. So here, and third step is response generation. Okay, so llm, like if you have any kind of llm like llama, okay, lava, and Gemini, whatever. Okay, so GPT, and here they give example like GPT, Coin, Llama, Cloudy, etc. They take the prompt. Okay, it will take the prompt and process query plus context. Okay, it will process with the help of query and context, reduce the hallucination since the model has access to the actual data. Hallucination means it will give a wrong answer, so it will reduce this thing. Okay, so final answer is final answer with reference or explanation depending on design. We got here final answer. So guys, so here you can see flow summary of diagram in bursts. Like if you have data, like if you have data in pdf format, text format, okay, or handwritten notes, whatever you have. Okay, so we need to create we need to load it first. You have data, this one, and after that you need to load it. Okay, and after that you need to split. Okay, so here I am going to split document 1, document 2, document 3, document 4. Okay, and after that we need to create embedding. What is the embedding? Like if you have a text format of any sentence like I am going to school. Okay, so we can pass it directly in our llm, so we need to create its in embedding. Okay, so we need to create embedding of every document. So here document first, embedding of this, and document second, embedding of this, like and embedding of third document, and embedding of fourth document. Okay, so here we need to took data, load, and split, and doing embedding. Okay, and these embedding I need to store in a vector database. Here, check here. So this is the process. Here I need to took some documents, and we need to load these things, documents, and we'll split it and creating embedding of it. And after that we need to store in a vector store or knowledge base. Okay, so vector store like files, pinecone, baby 8. We have lots of vector database. Okay, so we can store any of one. Okay, so after that here you can see, if you this is the what is the neural network. Okay, so this is the user. Okay, like you, this is the user. You ask the question, what is a neural network? So in your chatbot or in your model, you enter this question: what is neural network? What is neural network? After this you need to create embedding again for your question. So here embedding all here also embedding created of your question. And after creating embedding of this question, um, it will create a searching like semantic search. Okay, so it will give a searching according to your questions meaning. Okay, so what you are asking. So here it will use semantic search, or we have different search like similarity search, semantic search, cosine similarity search. We will see in next video. So here after searching, I mean by using semantic searching, it find the it find the what find here, it find like a answer based on the query what is neural network, and it match from which documents. In here you can see in which document you have your answer. Okay, by using similarity search, so it will provide a rank, or your rank of your document, like in first document, in third document you have answer, or in second document. So according to the searches, it will give a top and document, like if you have answer in these document, in these two documents, okay, not in 4 5. So it will give top 2 document, top 3 document, top 5, top n. Okay, and it re-rank here. And after that, from these document top rank documents, LLM generate the answer here. So user get your uh, I mean user get his answer. Okay, I think you got it. So here this is the process. You need to have data and load, split, embed, and store in vector database. And query also embed and retrieve from by using semantic search from vector database. Okay, after that prompt, query context, like prompt, like we have different prompt. So with the prompt or query context, here LLM generate your answer. Okay, from vector database with type of your query. So this is the query, like what is the neural network, this is also query. And here context, amount of information, and LLM generate the answer. I think you got it. And why this matter? Without rec, LLM only know what they were trained on. Okay, I mean outdated or hallucination. We have hallucination means we have, I mean, like if you ask the current GPT of sorry, current population of any country, so it will outdated answer. Now now if you have recently something, or this is not in our model, so if it is generate a wrong answer, then it will call a hallucination. With RAG you can update knowledge base means vector database anytime, and give model phrase actual context. So LangChain role providing the building block, loader, splitter. Loader means we can load our documents, splitter retrieval and change, so you don't have to reinvent the wheel. In short, LangChain turn your data into a searchable knowledge base and pair it with a LLM to give a contextual reliable answer. Okay, so here also we can see we have different documents, and we need to do create chunking. After that embedding, and here store in vector database. After seven, I mean user ask the question, and creating the embedding of this question. And here this search by using semantic search in vector database. After that it re-rank the documents, in which document you have your answer, and LLM by using context and query, I mean prompt what you provide to the LLM, it will generate the answer, and user got answer here. Okay, so user query, the this is the process, the user process. We can user combine submit a query or request, vector store representation, and similarity search. So here I mean we are going to store vectors and doing similarity search. Here you can see the vector is then used to perform a similarity search in a vector database. The goal is to find the most relevant information or context stored in the database that met the user query. Fetch the relevant information based on the similarity search. LangChain retrieve the most relevant data or context from the database. The step ensure the LangChain model has access the accurate contextually appropriate information to generate the meaningful response. And after that generating response. Okay, so these are the four steps. The retrieval information is passed to the language model like OpenAI and GPT, and the LLM process the input and generate the response. Take action based on the provided data. So here you can see step by step. Uh, LangChain, the core LangChain framework. So we will install all the requirement dependency for our model. Okay, we can install it by using pip. Now we need to import libraries like this. We have different libraries. Okay, so here you can import OpenAI. Okay, here also you can create prompt template, LLM, str output. So here we can see prompt template. Here LLM files placeholder like here, which actual input and give me a 3 career skill in 2025. Okay, so this is the prompt. Give me a 3 career skill in 2025. And LLM str output, output parser clean up, and it will give output in a string and cleaner format. Okay, and I think you got chain. What is the chain? Chain means we connect something. Okay, or we add something. We can combine different things together. Okay, so it is called a chain. So we have different things in LangChain. I think you got it. If you have any doubts, you can comments me. These things we have these kind of things in LangChain. Retrieval. What is the retrieval? Information retrieve system can retrieve structured or unstructured data from data sources in response to the query. Like if you have different data, like in PDF and text format, then you want to retrieve it because we want to do chunking. So before we need to retrieve it. Okay, then we will do. Sorry, before we do chunk overlapping. After that we need to retrieve it, and after that we need to do embedding and store in a vector database. Okay, so we retrieve something from documents, it's called the retrieval. And document loader load source as a list of documents, like we have PDF text data, okay, JSON data. So we need to load by using LangChain loaders. Okay, here you can see. Yeah, we have CSV loader. Okay, like this. So we need to import from LangChain underscore community dot document loader CSV loader import CSV loader. Okay, so loader equals to CSV loader, and you need to create like this data equals to loader dot load. Okay, or if you have very large data set, then you can use lazy load. So here we can load different documents. Like multimodality, the ability to work with the data that come in a different form such as text, audio, image and video. So this is called a multimodality, in which we use multimodals. Memory, information about the conversation that is persists so that it can be used in the future conversation. Okay, so we have memory. Structure output, a technique to make the chat model response to in a structured format such as JSON that match the given schema. So we got a structure output here. Tool calling, we have different tools. We can see here. A tool abstraction in LangChain associate a Python function with a schema that define the function name, description, and expected argument. You can also create it by your own tools like this. Create a tool using the tool decorator. Okay, so here this is the tool decorator from LangChain underscore core tool import tool. So here multiply, if you want to multiply a and b, and this is give you multiply two numbers. Okay, and you can use it in your code. Okay. Okay guys, so we have lots of things in LangChain, different tools, memory retrievals, embedding. Okay, I think you got it. If you have any doubt, please do comment. Bye bye.